All right, hi students. This feels weird. Okay, hi students. Today I'm going to go over Chapter 7, Lesson 1 with you about climate. You were to do that as homework yesterday, so hopefully you'll have a little bit of an understanding and I can just maybe help clear some things up or just kind of give you the details as to the whys for some of the things that are in there. There's a couple of concepts in there that you might need additional help with. So first of all, what is climate? Climate is the long-term weather patterns for a specific region, and those patterns are created by that region's latitude. You guys all remember latitudes? We've studied those before. So latitudes close to the equator are going to be affected by more direct sunlight, so they're going to be warmer. Latitudes more towards the poles get less direct sunlight, so they're going to be colder because the energy of the sun is thermal energy for us, and it heats things up. Okay? So latitude plays a role. Latitude plays a role. Latitudes closer to the equator are going to be warmer, and as you move away from the equator, whether you're going north or south, they're going to get colder. Okay, so that affects climate. All right, and also, do you notice that the globe has a lot of this blue stuff on it? These are called large bodies of water. And these large bodies of water affect those climates. Now remember how we talked about air masses that form over land are different than air masses that form over water? So the air masses that form over water are called maritime, and they have higher humidity. Whether it's cold water or warm water, they're able to get some water vapor in them, so they have a higher humidity. So now we're putting some of these pieces together from chapter 6. We're carrying those into 7. So these large bodies of water affect climates. So coastlines look different than like us in the Midwest. Living along the coastline is going to have a different climate than living smack dab in the middle of a continent. Those large bodies of water can actually regulate, make it less dramatic weather patterns. So it changes that climate a little bit. So, for example, we have some pretty extreme temperature differences in the Midwest, right? We can get brutally cold up here, brutally cold. We can also get ridiculously hot and humid, right? Well, people a lot of times travel along the coastline because that weather temperature has a smaller range, so you can pretty much count on it's not going to be 20 below along the coastline. It's going to be on the hotter end of the temperatures. So let me use my hand gestures for this. So in the in the Midwest where we're at, our temperatures can get stupid low, like 30 below, seriously. And then our temperatures can get stupid high. So we've got a temperature range like this, like 30 below to 105. Those can happen. But along the coastline, maybe they have temperature ranges more like this. And that's because the large bodies of water help moderate, help keep that range small, keep it a smaller average temperature. Because really, to even talk about average temperatures in Indiana, it's seasonal. So you have to look within the season. You can't just say our average temperature for this year was, because that would make really no sense. because we had really hot summers and then really cold winters. To average that is not really a number we sit on. Does that make sense? It's during the winter, this is our average. During the spring, this is our average. During the summer, this is our average. And during the fall, this is our average. We look at that because we're not near a large body of water. So our range is like this, depending on the season. Okay? So large bodies of water are one of the things that affect climate. And the reason that large bodies of water keep those ranges small is because of the specific heat index of water. So we go to a beach. Hopefully everyone's experienced that, even a pool, even going to a pool. The water is cold, but whatever you're walking on, ouch, 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 it's super hot. And they're all getting the same amount of sun. It's all right there. So what's going on there? Well, sand has a lower specific heat, so it takes less energy to heat it up. I'll let that sink in. It takes less energy to heat up the sand. So right away, when the sun comes up and it starts heating that sand gets hot pretty easily because it has a low specific heat index. It will heat up faster. It doesn't need as much energy to get hot. Water, on the other hand, has a very high specific heat index, which is a good thing because we don't want to be boiling all the fish in the lakes and streams and even in the ocean. We don't want to boil them. We want them to survive. So water has a high specific heat. It takes a lot of energy to warm up water. Okay, so you would normally warm up smaller amounts. You could warm those up quicker because you can apply more energy to a smaller amount than you could to a really huge amount of water. Okay. We are going to do a lab activity about specific heat, not this week, and it's not looking like next week, so it'll probably be the first of the following week. The first part of the following week, we'll do a lab activity where you can do some calculations about water and specific heat. It's very math oriented as well. All right, so specific heat of the water is what keeps that average smaller because water's not heating up and cooling down. It just takes that energy in and takes it in and takes it in and takes it in and okay, I'll go up a degree. And then it takes it in, takes it in, takes it in, okay, I'll go. Whereas everything else around it is heating up and cooling down much faster. That also creates wind. Like there's a breeze at the oceans and waterfronts, and there's a breeze because we have things that are heating up fast because they have a low specific heat, and then we have the water that's heating up rather slowly, and so then that creates wind because that creates high and low pressure systems. Okay? So hopefully you can connect that. Most of you did so well on that test that I think you're ready now to take all that information we did in weather and understandings about high pressure and low pressure and cold air sinks and altitude is less dense. Higher in altitude is less dense. Colder temperatures, less pressure. Okay? All right. So latitude affects climate. Latitude. Large bodies of water affect climate because of water having a high specific heat index. Things don't heat up and cool down, so the average temperature stays really small along bodies of water. And then altitude affects climate. Then you've seen pictures or you've been in mountains and you know that it's colder up there, okay? And there's a really great diagram on page 228, and I'd like for you to look at that. Really cool diagram in there. It's about the altitude. So these two cities, page 228, These two cities are on the same latitude in Colorado, the exact same latitude, all right? One of them, the one that has the higher elevation, January's average high temperature is negative 1.5 degrees Celsius. Whereas the other one that has a lower altitude in January, its temperature is 5.9 degrees Celsius, its average temperature, okay? So that's an example. They're on the same latitude, but they have different altitudes. So that's an example of how altitude can affect the climate. Mountains have certain climates. If you've done any mountain, seen pictures or gone anywhere where it's mountains, you'll know it's a different climate. If you go to Tennessee and you go up in the mountains, it's cooler up there. All right, which leads us now to page 229 in the rain shadow event. So if you have, and guys, you need to read those little captions in that, because it gives you all the information and explains it very well what's happening in the rain shadow. But so you have wind coming usually from a body of water, because the mountains are usually inland from a body of water because of plate tectonics and how things formed. So we have this wind bringing warm, humid air across the valley, and then it comes, here's this mountain, boom, there's a mountain there. So this wind's like, okay, can't go through the mountain, so it starts moving up the mountain. All right, it's kind of like hitting a cold front, because what happens with altitude? Colder temperatures. So this warm air ends up moving up and getting cold. What happens when warm, humid air gets cold? Condensation. If it continues, the condensation gets heavy enough, what happens? Precipitation. Snow, rain, depending on the altitude of the mountain area. So now we've got precipitation falling on that side of the mountain, okay? So all this humidity was released before it got completely over the mountain. So now I've got air moving over the mountain, but it no longer has any humidity. It released it all in the form of precipitation. So what is the other side of the mountain going to look like? It's going to look desert-like, because it doesn't get a lot of rain, because it happened on this side of the mountain. That's called a rain shadow. This side, the desert side, is called the rain shadow. It's the shadow after the rain. It all already happened. All right? The visual, the diagram visual thing on 229 is really good. So especially if you're a visual person, you should look at that, and definitely look at the captions 1, 2, 3, and 4. It walks you through it again, like I did. All right, so how do we classify climates? There's all kinds of climates. Oh, look at this classification system. Look at all those. You don't have to memorize all those, okay? If you're a climatologist, you do. But be aware of them. It's very similar to how we named our air masses. You know, if it formed over a continent, it's going to be dry because it doesn't have humidity. If it formed over water, it's going to have humidity. It's going to be called maritime. If it's formed close to the equator, it's going to be tropical because it's warm. If it's formed close to the poles, it's going to be polar because it's cold. So it's very similar to that. And some of those terms are even used within classifying the climates. So what they look at is temperature and precipitation, which were two of the things we looked at to name our air masses. They were the two biggies. And then the other thing is they look at what vegetation is able to grow there because of the temperature and precipitation. I mean, it looks very different in an Amazon rainforest compared to Arizona. Cactus versus all kinds of plants and trees and foliage. Vegetation, temperature, precipitation, they look at those three things, mostly temperature and precipitation, and they look at those three things to classify it and name it. So that's how they're naming them. Now, microclimates now are being realized, that there's microclimates, and a lot of them are created by us. So urban areas like the city, like Chicago, maybe you've heard of Chicago being called the Windy City. Well, there's a lot of concrete in a city. There's a lot of asphalt in a city. These things absorb and release heat more than soil. They're doing absorbing and releasing heat more than a normal natural habitat would. So these create changes in pressure. That means wind, right? So these, they call them urban heat islands, create its own little microclimate. So you can expect there to be wind in Chicago. Not because of the location of Chicago on here, but because of the buildings and the concrete and the asphalt that are in Chicago. So microclimates, some of them occur naturally, but we've created a lot of them, okay? Some of them can occur naturally. You can all of a sudden, there's a valley, and then all of a sudden there's a little wooded area, woodland area or something. Those can happen, like forests, the top of a hill, because of plate tectonics and the formation of hills and valleys, there's microclimates there. So they're not all man-made, but a lot of them nowadays are man-made because of the urban heat islands. Urban meaning the cities, the city creating these new microclimates because of the specific heat of the materials used in a city. Some cities have even gone to like painting over the black roofing, the black rubber roofing. Some of them now have gone to painting over that with a light color, usually white, so it reflects it instead of absorbs it, which reduces the amount of cooling that a building might need to keep the building cool enough to live in. They're engineering this kind of stuff now. They've realized this is creating these microclimates, so they're doing some changes. Maybe you've seen where cities are planting gardens on rooftops and stuff instead, so that they can absorb the CO2. It's also not a black top. It's going to release heat differently and take it in differently, so it helps with that microclimate of that city to do these kinds of things. And the breathing reduces pollutants and CO2, which is another greenhouse gas, so it just really can change temperatures to not have a lot of plants and then have a bunch of concrete and asphalt. Okay. There's a place in Alaska that I've seen pictures that they've had to abandon the houses because the permafrost has melted. And when they originally built these houses 100 years ago, maybe more, 200 years ago, permafrost was permanent. Permafrost, the ground was frozen permanently. So they would build these houses on these posts that worked in the permafrost, and then it refroze, and boom, it's solid. Foundation is good. Well, now the permafrost is thawing because of climate change, so they've had to abandon. Sorry, move around, let it know I'm still in here. They've had to abandon these homes because permafrost thawed, and now the foundation is just falling willy-nilly, and then the homes are not livable anymore. So climate affects housing, shelter for us and for all organisms. So depending on what type of animal you are or organism you are, because it affects plants too, you can survive or not survive in certain climates. So a climate also determines how you're going to seek shelter. Polar bears dig really, really deep. And I've mentioned a couple times how much I love snow. And in the blizzards, we would dig in the snow banks. We would dig down, and we wouldn't even have to go very far down. It's, just here a couple feet down. And it's super warm because you're insulated from the wind and, the wind, mostly the wind. And you get down there and your body heat can be insulated from the snow, and you stay toasty warm. And we used to take naps. We get down there in our little tunnel, we dig out a nice spot, and we take naps down there. I can remember sitting in there and reading books just for fun because it was something different to do. But polar bears do that. They dig down in and they take shelter in the snow, and they build out dens in those snow areas and keep warm. All right. I think I'm going to make sure that I've covered everything you need in order to answer. Oh, I did not cover actual information about like the Gulf of Mexico. You guys know the Gulf of Mexico, right? Familiar with it down? Gulf of Mexico. That's a warm ocean current. So that's part of why our southern states along the Gulf stay warm and have humidity. They're warm and humid down along there. Okay. The Gulf of Mexico is known to be warming up, and there's actually a lot of dead zones. It's too warm for organisms to live in it anymore. Except sometimes not so good algae can live in the warmer waters, and then they eat up all the dissolved oxygen, and that's a whole nother story that we'll talk about. All right. So yeah, the Gulf of Mexico is actually getting too warm, so that's a whole new problem. But it's warm, humid air coming up off the Gulf, and that's what those coastline cities rely on. That's why people go visit there in the winter from the Midwest, where it's cold and crazy. We go south to enjoy some warm air, right? All right. Have a good day. Reach out to me via email if you have any questions.